So starting with the first thing, organic chemistry. ठीक है, आपने any idea कि what is organic chemistry about? Any idea?
Okay, not really.
So it's basically the chemistry of carbon compounds. ठीक है, chemistry of carbon. So compounds that are made out of carbon. You've got like ethanol. ठीक है, that's C2H5OH. Carbohydrates like glucose. That's C6H12O6. You've got fats, proteins, etc. So all of these are carbon-based compounds. Why is carbon so important? The reason carbon is so important is that now the reason carbon is important is that most living organisms, two of the main things, living organisms, including us, which includes animals and plants, and things that are made out of them. I mean, for example, clothing that's made out of wool, which is an organic substance. Leather products, fossil fuels. So products derived from living organisms. You get lots of stuff derived from fats, fossil fuels. They're all carbon compounds. So when it comes to chemistry, when it comes to chemistry, it's a lot of the chemistry basically depends on like most of the chemistry that we're talking about, medicines, etc., fertilizers, pesticides, insecticides. All your petrochemical products, petroleum, that's all organic. So you can kind of safely state that most of the chemistry that's happening around you, that's organic chemistry. It's not inorganic is the rest. Inorganic is the salts, like NaCl is inorganic. Anything that's not carbon related is inorganic. So the proportion of organic chemistry is a lot that's happening around us. Okay? Every reaction that's happening in our body, in our cells, in the stomach, in the blood, everything in our brains, every reaction that's an organic chemistry reaction. Okay? And we are all made out of carbon. Okay? That's one thing that's very important. So why did nature, why did nature make carbon? Why is everything made out of carbon? Why not any other substance? क्या reason हो सकती है उसकी? Like why are plants, trees, animals, etc., everything, why are they all made out of carbon? Any idea?
No, sir, I don't.
So I'll explain. How many bonds does carbon make?
4.
Okay, so it makes 4 bonds. That's one reason. Like if you like we're all made out of bits and pieces joined together, right? Small atoms joined together. So you make very good structures if something is making 4 bonds. You can't make a very big structure if something only makes 1 bond. Uh, it's like Lego pieces. If you're joining them together, so a piece that can make many bonds, that's you can make more complicated structures out of it. So carbon makes 4 bonds, and it's a small atom. So small atoms they always make stronger bonds. So you got silicon that can make four bonds as well, but carbon can make stronger bonds. So you can't. So it would be very hard to make complicated structures out of some other atom. Although organic compounds have other things in them, but the main structure is based on carbon. So For example, carbon over here can make 4 bonds. Maybe let's say make 1 bond with oxygen. And then you've got you've got another. अच्छा board थोड़ा hang हो रहा है, just bear with me, ठीक है? So you got another carbon. Maybe there's a carbon after that. ठीक है? फिर you can have other carbon atoms, ठीक है? And so on. And the structure could continue endlessly. It could have many bonds. तो ये सारा अच्छा उर्वा मैं जल्दी से बस रिपीट कर रहा हूँ कि what we just did so far is कि I told you guys that organic chemistry is all about studying carbon compounds, all sorts of compounds, ethanol, glucose, fats, proteins, these are all carbon compounds. Why is carbon important? Because why are carbon compounds important? Because all living organisms that you see around you, animals, plants, humans, etc., every living organism, from the smallest to the biggest, they're all carbon compounds. And there are lots of products that are derived from it. It's from the like petroleum, lots of products that work with them, medicine, etc. Uh, Leather, everything. They're all carbon compounds. And why did nature choose carbon as the building block of life? All living organisms are made out of carbon. So why was carbon chosen? Because carbon can make 4 bonds. So if something can make 4 bonds, you can make complicated structures out of it. I can show you some of the complicated structures like the heme group, let's say. If I mean, this is for example, this is a heme group, although this is another version of it. Every point over here is a carbon atom. Like if I open image in a second, open image in new tab. I said every point over here is a carbon atom. This is a carbon, this is a carbon, this is a carbon. So you can make complicated structures out of it. Like it would be very hard to make complicated structures out of atoms that can make very few bonds. Okay? So ये बात clear है कि why is carbon important? Is this clear, Abna? Or why is this clear?
Yes, sir.
जी sir.
So just like the structural formulas that we did, the first thing is, remember organic chemistry, carbon compounds. And not just carbon, it could be other atoms as well. You can have other atoms, but mainly it's carbon. Okay? So the first thing is structural formulas, drawing the correct structural formulas. We just did that. So drawing the correct. Now, structural formulas are very important in this. Drawing the correct structural formula. So I'm just going to repeat that group 7 makes 1 bond, right? Any atom from group 7. Group 6. You get that one makes how many? That makes 2 bonds. 5 makes 3 bonds. And 4 makes 4. It makes 4 bonds. And you've got hydrogen that makes just 1 bond. And I'm going to write the names of some of the atoms, carbon and silicon. These are the most important atoms. Group 5, you've got nitrogen, phosphorus. Then you've got 6 would be oxygen and sulfur. And 7 would be fluorine, chlorine, bromine. And you've got iodine as well. Anyway, so you've got all these atoms. The first thing is, now organic molecules can be very complicated and they can be very big. So for example, I've got, so this is the first thing. So I'm going to draw a kind of a complicated organic molecule. And this one So here's an organic molecule. और यहाँ पे ना there is anyway, so let's say this is the structure of an organic molecule, and I've drawn an incomplete structure at the moment. Okay, so let's say I have a bucket, and that bucket has a lot of hydrogen atoms in it. Do you remember hydrogen makes one bond? So I've got a bucket that's full of hydrogen atoms. Now look at the molecule over here. ठीक है, ये भी हम वही कर रहे थे. Look at the molecule over here and tell me if somebody is this a correct structure or not? Is the carbon over here correct or not? This one. ये सही है गलत है?
No, incorrect.
That's incorrect, right? It's so what should I do? Like I've got these hydrogen atoms.
Add another bond with carbons and remove the other carbon. Double bond.
So I should add a hydrogen atom over here, right? Now this carbon is fine. Okay, so now this one is fine. Urva, Amna, is this clear?
No, sir, I don't get it.
No, carbon, how many
How
bonds?
is it incorrect?
No, how many bonds should carbon make? It's in group 4. It should be making how many bonds, Urva? 4?
4 bonds, yeah.
तो उससे पहले क्या था कि if you look over here, how many bonds was this making? कितने it's? I mean, this carbon, that's one bond over here, one over here, one over here. So this one is making 3 bonds, right? You clear?
Yes, sir.
So इसका मतलब it should be
So
making
it's supposed to make like 4 bonds. It's supposed to make 4 bonds, right?
Exactly. So you should add a 4th bond. Or the bucket में से ना pick up a hydrogen atom and attach it with this one. ठीक है? तो board hang हो गया, just a second. अच्छा, anyways, so I've put a hydrogen atom over here. वो कोई भी atom हो सकता है. I'm just using hydrogen atom at the moment. ठीक है? Or is this clear? We're just learning how to draw correct structures. Achha, what about this carbon now? Is this correct? Is this correct? Is it making 4 bonds?
Yes, it's correct.
It's correct. It's making 2 bonds here, one over here, one over here. So this is completely fine, right? There's nothing wrong with this. Achha, this is fine. What about the next one?
Okay.
Okay, this one is also making 4 bonds. Achha, what about this carbon over here?
It's wrong. Need hydrogen.
So it should be making 4 bonds, right? Should have another hydrogen atom, right? Similarly, this carbon is also making 3 bonds. It should be making 4 bonds, right? So I'm going to add a hydrogen atom, right? This one is also making 3 bonds, and I'm adding another hydrogen atom, right? So now all my carbons are correct. This one is fine. This one is also fine. This one is also fine. You clear like the first thing, I've corrected all the carbon atoms by just adding hydrogen atoms. I could have added anything else, but I'm using hydrogen atoms. Okay. Amna, Urva, is this clear?
Sir, do we always have to add hydrogen? Like
नहीं, मैं तो अभी वैसे as an example, I've
कोई
just
भी add कर सकते हैं.
हाँ, you could have added anything. ठीक है. तो अभी बाद में अभी हम सिर्फ पढ़े कि by looking at the molecule, if you can figure out whether the structure is correct or wrong, ठीक है. तो अभी तो हम बस I'm just using hydrogen as ताकि वो उसको complete कर लें, ठीक है. अच्छा, anyways, let's look at the other atoms. Fluorine is supposed to make how many bonds? That's group 7. That's 1 bond, right? So all the fluorines are fine. They're all making 1 bond. There's nothing wrong with them. Oxygen is supposed to make 2 bonds, right? So is this fine or not? This one. It should be making 2 bonds, right?
Yes.
So instead, I'm going to put a hydrogen over here, and I'm going to put a hydrogen over here as well, because now these oxygens are fine. Now they're fine. और अब ये पूरा structure, the whole structure is correct, right? There's nothing wrong with it. Is that clear?
Yes.
Yes, sir.
Okay, this is the first thing you have to remember, that when you draw complicated structures, each atom should be making the right number of bonds. Otherwise, the structure, I mean, that's the first very basic thing. You have to learn to draw correct structures. So let's say I've got this molecule now. I've got carbon, carbon, carbon. There's a double bond. Carbon, there's an N, right? So let's say that's my molecule. And again, I've got a bucket of hydrogen. So how many hydrogens do I need to add over here? First carbon ke saath.
3.
Right? There should be 3 hydrogens with it, right? What about this carbon? How many hydrogens do I need to add with this one?
2.
So there's going to be 2. How many hydrogens do I need to add with the third carbon?
1.
Okay, so there's going to be 1. What about this one?
Also.
Okay, so it's also 1. I say it doesn't really matter. Okay, वो ऊपर की तरफ add करो या you put it downwards, it's the same thing. Okay, there's no difference between the two, as long as it's connected to the same carbon atom. How many hydrogens with the nitrogen over here? Nitrogen, remember, is group
2.
Okay, so it's group 5. It should be making 3 bonds. तभी वो एक ही बना रहा है ना, so it should have 2 more hydrogens, right? So that's it. So you got the correct structure of this molecule. So let's do. Actually, mostly वैसे hydrogen ही होता है, ठीक है? It's mostly hydrogen. But it could be any other thing as well. So let's say I've got this structure now. I've got I've got this structure. So then let's put a double bond somewhere. So how many hydrogens with this carbon atom?
Which one? With the
This one. नजर आ रहा है?
G. 3.
नहीं, it's
2. 2.
so you need 2 hydrogens with this one, right? What
4,
about
4 with 2 and 2 carbon atoms with 1 hydrogen.
okay, ठीक है. मतलब top वाला है. I mean, it's again hanging. I said top one over here. That's going to be 2 hydrogens, right? This is going to be 2 hydrogens. This one will also have 2 hydrogens, right? I said this one will also have 2 hydrogens. This one will have 1 H. This one will have 1 H. Okay. So is this clear?
Yes, sir.
So we'll practice this a lot. Urva, Amna, is this clear?
Yes, sir.
I said this is known as a cyclic compound. I mean, you can just look at the molecule and you can figure out that it's cyclic, right? And this other one is known as aliphatic. Aliphatic means that it's not cyclic. It's the opposite of cyclic. That it's in a chain form, like it's a long chain. And these organic molecules could have many, like you could have lots of atoms. Now so we're going to start with the first one. I'm just going to jump in, TK. So remember, you've got all sorts of organic molecules, TK. They're carbon compounds. And they're infinite organic molecules. Just in my own body, they're infinite organic molecules. Because it's just a bunch of carbon atoms that are all joined together. Okay, so you've got all these particles that are like in a human body, they're infinite different possibilities. Like any organic random molecule that I make up, that probably exists in nature. Because every plant has infinite organic molecules. There are hundreds of billions of organic molecules inside a plant. So you've got infinite possibilities of organic molecules. Like if I say that there's a molecule like this, in nature this one will have 2 H's, this one will have 3 H's. Achha, spot. Achha, this one will have 3 H's as well. And I've got 1 H over here. Achha, can you spot my mistake over here? What did I do wrong? What did I do wrong over here?
Sir, there's extra hydrogen in the carbon.
You get in this carbon, right?
Yes.
Okay, it should not be making 5 bonds. At the moment, it's making 1, 2, 3, 4, and 5. So ये गलत है. It's not supposed to make. So I got to remove this. Now the molecule is correct. Carbon is making 4 bonds. This one is making 4 bonds. This one is also making 4 bonds. 2 over here, 1 over here, 1 over here. So that's 4. So this was the problem, right? So anyways, you need to spot this first, that you have to know, okay, which one is the correct structure. So now moving on, you've got infinite different organic molecules. So there's like my red blood cell, that's an organic molecule. My red blood cell is actually composed of many different smaller organic molecules. My white blood.
Glucose, is it an organic?
Most of the living stuff that you have, your hair, your nails, everything that's kind of organic. Okay, it's going to be something similar to, like if you look at a structure of human hair. Let's say what is so not sure if Google is going to give us that's like the chemical structure. That's still probably this one. So so you can spot that it's got, you can't really clearly see this, but it's got carbon atoms in it, right? Cysteine, so it's got carbon atoms anyways. So most of the stuff that you're made up of, except for your bones and teeth, most of the other stuff that's organic. Plants are organic, everything living is mostly organic. Actually, now moving on. The problem is that you've got so many organic molecules. There are lots of organic molecules around you, that you need a classification system, just like the animal kingdom. Like you've got so many different species of animals that you start classifying them. Plants, you've got so many species, so many different types of plants that you classify them. You have a classification system. In organic chemistry, you've got a classification system as well. And that classification system is known as a homologous series. So that's like so you basically, what you do is you start the infinite different molecules that you have. You start classifying them based on certain properties, right? Like for example, like why do you classify in the animal kingdom? You classify certain things as reptiles, right? So you classify them according to certain properties, like they lay eggs and they are cold-blooded, right? So you catches
Scale.
so basically you've got a classification system, right? And that classification system is based on certain properties, right? So you're going to do the same thing with all these hundreds of billions of organic molecules. You're going to classify them according to certain properties.
Sir, how do you pronounce this word?
Homologous. The homologous series is a classification system. So it's a family of organic compounds having certain similarities. So having similar what? So that's the first question that you actually get. They ask you to give an explanation of the homologous series. So you classify these organic compounds, billions of them, into a family having certain similar properties. Number one, they have similar chemical properties. Similar chemical properties.
Okay.
So maybe they react in the same way. For example, there would be some, for example, like there would be some families of compounds that would be soluble in water, even though that's a physical property, or they might react with water, right? So if they react with water, that's a chemical property that would be similar to all of them. They might react with sodium. So that would be a chemical property that would be similar to all of them. So based on similar reactions, like what does similar chemical property mean? That they're going to have similar reactions. As a second, they will show trends in physical properties. So now with physical properties, the thing is they can't be exactly similar. You can't have the exact same boiling point. So trend ka matlab hai ki if one of them has a low boiling point, the others will also have low boiling points. If one of them has a high boiling point, the others will also have high boiling points. If one of them is soluble, the others would also be soluble. But it's not going to be exactly the same. Okay? You clear? So you take the organic molecules in my body and you classify them. If they show the same reactions and if they have the same kind of physical properties, but not exactly the same, but kind of milti julti physical properties, then we'll probably put them in the same family. I said now with physical properties, I'm just going to add a few points over here, and that is K. And this applies to all organic molecules. That as the size of the organic molecule increases and it becomes bigger, as the size of any organic molecule, no matter which family it is in, as the size of the organic molecule increases, what happens is that the melting and boiling points, they increase. So if a molecule is bigger in size, so it's going to have a higher boiling point and melting point. As a secondly, its solubility will decrease. If the size increases, if you have a bigger molecule, it is less likely to be soluble. Like if I take my hair out, right? The human hair, that's an organic molecule, but it's a big molecule, right? It's a very big, it's got a big size. It's not soluble. So solubility decreases if the size increases. As a similarly, there would be other thing. There's viscosity is a thing. Viscosity is the thickness. For example, look at honey. Honey is an organic molecule as well. Honey is very viscous. That means it's very thick. It doesn't flow easily. And if you look at petrol is an organic molecule as well, but that has very low viscosity. ठीक है, तो अगर आप देखो ना, petrol है, engine oil, you've got honey, the viscosity, the human blood is kind of, I mean, it's got a lot of water in it, but purely organic compounds. Honey, you've got petrol, these are organic substances. So they have different viscosity, they have got different thickness. ठीक है? Candle wax also flows, but it flows it doesn't flow easily. Is that clear? Viscosity का मतलब पता है? Clear है?
Yes, sir.
Yes, sir.
So melting and boiling points increase and the solubility decreases and the viscosity increases. And there's another one that most organic molecules are flammable, which means that any organic compound, like if you take a tree that's an organic compound, it burns, right? They're flammable, but they have different flammability. Some of them burn very easily. Some of them they don't burn that easily. So if the bigger the molecule, the less flammable it's going to be. So flammability decreases. Okay, so you must have seen that you've got petrol that burns very easily, right? And you've got cooking oil that's on the stove, right? It doesn't burn, it doesn't catch fire. Because the cooking oil molecule is very viscous, it's very big in size. Whereas the petrol molecule, that's the gasoline that you add in your cars, that's it's got a smaller molecule. So that one is less viscous, but it's more flammable. And cooking oil is more viscous, which makes it less flammable. ठीक है तो जितना बड़ा molecule होगा that's it's not going to burn that easily and it's going to be very thick as well. ठीक है तो ये इसका याद रखना कि they show similar trends in physical properties if they're in the same family, but the physical properties are not going to be identical and the physical properties they change with size. ठीक है the size of the molecule has an effect on the physical property of the molecule. ठीक है is this clear? I'm not clear. Urva, Swaib.
Ji, sir.
Yes, sir.
Yes, sir.
अच्छा third पे आ जाते हैं. What else? How do you classify them in the same homologous series? So the third point is like why do you put them in the same family of compounds? They have the same functional group. Now, what is a functional group? A functional group is basically a group of atoms that or a group. So it's an atom or a group of atoms, or basically it's a particular structure in a molecule. So it's a particular structure in a molecule that determines its chemical reactions or chemical properties. So as an example, you've got organic molecules are like large, complicated molecules, right? So not the whole molecule reacts. For example, I've got a molecule and this molecule is this. So the name of this molecule is it's called an alkene. We'll talk about that later. Okay, so I've got this molecule and I've got this other molecule as well, which is slightly bigger in size. Okay, so how many hydrogens with this? That will be 3, right? Remember, each carbon should be making 4 bonds. This one will have 1 H. This one will have 2 H's, right? 3 H's with this one. This one will have 1 H and this one will have 2 H's. अच्छा कुछ गलत नहीं किया ना? Everything is fine, right? Carbon is making 4 bonds, 4 bonds, 4 bonds. All of them are making 4 bonds, right? Now, if you look at these two molecules, they're completely random molecules that I've drawn. They have a certain similarity that both of them have this thing, that they've got a carbon and a carbon double bond. This one also has a carbon and carbon double bond. So there is a huh? That's okay. So that is known as a functional group. It's a structure in a molecule, and most of the reactions they happen with this particular structure. I mean, the rest of the molecule is not doing anything. In these reactions, all of the molecules that are going to come and react with it, they're going to react with this thing. So this is the structure, this is the part of the molecule that's going to react with it. Okay, we'll do the reactions later, but what I'm trying to state is that keep it simple. The general idea is that you've got a big molecule, right? But not the whole molecule undergoes a reaction. It's just certain portions of the molecule that undergo reactions. These are known as functional groups. The parts of the molecule that undergo reactions. And it's kind of a common reaction, that's with bromine. That's known as a bromination reaction. The bromine molecule comes and reacts with this part. The bromine molecule will also go and react with this part. So that's the functional group. Any molecule that has this thing is going to be classified as the same. It's going to be classified in the same family. Okay, so that's what a functional group is. And many molecules have different functional groups. You've got examples there, like if you. So you've got all sorts of functional groups, like, and we'll talk about each one independently. So for example, I've got, I've got this one. So what do you think is common in all of them? All of them have an OH group. Not all of them, the first four. Look at the first four. They've got a carbon connected to an ONH. This one is a carbon. They've got different structures, but that's called an alcohol. You will study that later. But just the idea of the functional group, that when you have a reaction, the whole molecule does not take part in the reaction. A certain part or a certain structure in the whole molecule is going to take part in the reaction. Okay, so if you think of us as the whole organic molecule, so if I want to, let's say, write something, I'm just going to use my right hand. My whole body is not going to do anything. Okay? So the same applies to this molecule. The whole thing will not do anything. It's just one portion of the molecule that's going to take part in the reaction. Okay? So idea clear? Okay, what's a functional group? Is this clear?
जी sir.
Number 4. Number 4 is that they have the same general formula. So that's number 4. They have the same general formula. If they're in the same family. I say ये दोनों एक ही family में, because they have a certain similarity. They have the same functional group, right? I said, now, what is a general formula? A general formula is that it's a formula that you use. The general formula for an alkene, I'll just give you an idea that for general formula for an alkene is CnH2n. Okay, that's an example. Since I've drawn an alkene in front of you, so I'm going to use that. I said CnH2n. What that means is that the number of carbons and the number of hydrogens, it's going to be 1:2. Like if I have 3 carbons, I'm going to have 6 hydrogens. If I have 4 carbons, I'm going to have 8 hydrogens. Look over here, I've got 3 carbons. So that means I'm going to have, if you count the hydrogens, it's going to be 6. Look over here, I've got how many carbons? I've got 1, 2, 3, 4, 5, 6. So I've got 6 carbons. If you count all the hydrogens, there would be 6 hydrogens. No, not 6. They're going to be 12 hydrogens. You can count all of them. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. मुझे directly किसना पता लगा है? I just use this CnH2n. Like if there are 6 carbons, then it's 6 into 2, that's 12 hydrogens. Okay, so idea clear है कि both of them have the same general formula. General formula is like a shortcut to figure out how many atoms you've got. Okay, this is C3H6, this is C6H12. Both of them have the same exact general formula. Is that clear? Or you've got a 5th option as well, which is, अच्छा लेकिन ये clear है?
Yes, sir, clear.
अच्छा फिर एक और option है that successive members in a homologous series, which means in the same family, they would differ by CH2, have a difference of one C, have a difference of CH2. ठीक है, what that means is that if I draw two, if I draw two successive members, successive means that there'll be a difference of one carbon atom. Like if I draw one alkene, and then I draw a 4 carbon atom alkene. Okay, so I'm drawing one alkene and I'm drawing a 4 carbon atom. So this one will have 2 H's, right? Okay, you have to be good with this. This one will have 3 H's. 1 H, 1 H, 3 H's. Why do they differ by CH2? This one, according to the formula, is 3 carbons and 6 hydrogens, C3H6. This one is 4 carbon atoms. You can count the hydrogens, but there's going to be 8 hydrogens, CnH2n. Okay. So what is the difference between the formulas? The difference between them is कि एक carbon का फर्क है, and there is a difference of 2 hydrogens. यहाँ पे there were 6 hydrogens, over here there are 8 hydrogens. So that is what is meant by the last one. So I'm just going to repeat everything. ठीक है? You classify all these billions of organic compounds into different families. How do you determine that they belong to the same family, that they're going to have similar reactions? If they have similar reactions, similar chemical properties, if they show trends in physical properties, so they have some kind of similarity in the physical properties, they'll be put in the same family. They'll also have the same functional group, which means that it's going to be a structure in the molecule that would be similar in all of them. So this is an example of an alkene. All alkenes have carbon and carbon double bonds. So they're two different molecules, but they have the same functional group. This one has a double bond between carbon atoms. This one also has a double bond between carbon atoms. They will have the same general formula. Just यहाँ पे मैंने apply किया था. Both of them have the same general formula, which is CnH2n. And if you talk about successive members, that means एक 3 carbon atom wala and the other one is a 4 carbon atom one. So the difference between them is going to be of 1 carbon and 2 hydrogens. Okay? So you have to remember these 5 properties of a homologous series on which you classify organic compounds into a homologous series. Okay? ये बात clear? ये वाला.
Yes, sir.
Urva, Amna, is this clear?
Yes, sir.
जी sir.
So I'm going to do the first family of compounds, the first one, just the first one. I mean, they're like 4 or 5 that you have to study. So let's do the first one. They are called alkanes. So these are known as alkanes. And the general formula is CnH2n plus 2. We'll come back to the general formula. So if I classify something as an alkane, what would the molecule look like? For example, if I classify something as a dog, what would it look like? So if I classify something as an alkane, what would it look like? First thing, it's going to be a hydrocarbon. What does that mean? It means it will only have carbon and hydrogen atoms. Nothing else. No other atom. Second thing is it's going to be a saturated molecule. There's a term that's called saturated, which means no double bonds. All bonds are going to be single bonds. So no two dashes anywhere, just a single dash, single bonds. Okay, that's so any molecule that is saturated means that it doesn't have a double bond. I mean, this is not saturated, right? Okay, so an alkane is saturated. So I'm going to draw the first one. These two properties in alkanes. I'm going to draw a random molecule, but it's going to be an alkane. So it's got only carbon and hydrogen atoms. And all of them are going to be single bonds. So this carbon will have 3 H's. This carbon will have 2 H's. This carbon will have 3 H's. Okay, that's an alkane. You clear that this is an alkane? Because only carbon and hydrogen atoms and all of them are single bonds. Okay, you clear? Is this clear?
Yes.
And you can draw any complicated alkane. Like I can draw a bigger alkane. Okay, let's say this one is really big. Okay, so all of them single bonds. This carbon needs 3 hydrogens, right? This carbon needs 1 hydrogen. This one probably needs 3. So this one also needs 3. This one needs 2 hydrogens. And this one needs 3 hydrogens. So bonding complete, all of the carbon atoms are making 4 bonds. And that's an alkane as well. No, Urva, is this clear?
Yes, sir.
जी sir.
That's a general formula apply kar lete hain. N is the number of carbon atoms. Cn H2n plus 2. So N is 3 over here. So it's going to be C3. And so N is the number of carbon atoms. Just one second. N is 3, right? So put that in the general formula, CnH2n plus 2. So that's C3. H would be 2 times 3 plus 2. So kya bana? That's C3 and H would be 8. So you can count it. It's C3 and there are 8 hydrogens around it. Is that clear? Or फिर general formula I'm going to apply it over here. What's N number of carbon atoms? That's 1, 2, 3, 4, 5, 6, 7. So I've got 7 carbon atoms over here. So यहाँ पे N has a value of 7. And I'm going to use that CnH2n plus 2. So it's going to be C7. And H would be 2 times 7 plus 2. What is that? C7H 16. 14 plus 2, that's 16. So you can go and count this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So clear है general formula काम कर रहा है. Is that clear? ठीक है, is this clear?
जी sir.
So बस अब एक काम करना है कि randomly ना just draw me alkanes. Whether it has, I mean, just draw random molecules that are alkanes. There could be a 1 carbon atom alkane, there could be a 2 carbon atom alkane, there could be a 4 carbon atom alkane. So any complicated, just draw me, actually the assignment है कि draw me 5 alkanes.
Okay.
जितने मर्जी बड़े हों, ठीक है? Just make sure, अच्छा, fill in the hydrogens later. Just draw the carbon atoms first. And then you, according to the requirement, कि 3 चाहिए, इसको 1 चाहिए, according to the requirement, fill in the hydrogen atoms, ठीक है? Like this one, for example, I'll just do one more. Okay, you can, like if I want to draw a 4 carbon atom alkane, right? So the 4 carbon atoms could be, I mean, they could be in a straight line, and then you can fill in the hydrogens, or they could be like 1 carbon atom could be over here. So there could be many ways to connect the 4 carbon atoms, right? What's there are 5 carbon atoms. So draw me 5 alkanes. ठीक है? ये homework है. चलो ठीक है ये फिर
Okay.
अब मोस्ट लाइकली आई थिंक we'll have Wednesday ठीक है we'll do this on Wednesday as well ठीक है
Okay, sir.
चलो okay everyone
Allah Hafiz.
Cheers.